Okay, you guys, so today we're talking about just solving equations. So the last section we were graphing and solving them. Well, today is all just algebra, okay? So we're just solving equations, and we'll be solving some inequalities as well. So for our first example, so it says we're solving a system of linear equations, and a system of linear equations is just going to be a set of two or more equations using the same variables, okay? So you'll have like x, y, and then we'll also have x, y, and z at the end today, so we'll be solving for 3 variables with 3 equations, okay? But it's the same thing that we'll do with 2 equations, okay? And then our solution is always going to be the ordered pair that makes the solutions true. So even when we solve this out, if you solve for x, you also need to solve for y because your solution is that ordered pair. It's not just your x value, it's not just the y, you need both of them. Or you would need x, y, and z, okay? So the first one, we have x plus 2y is equal to 3. And then we have x minus 2y is equal to 4. What's one way that we could solve this? Kaden, what do you think?
Isolate y.
Isolate way? Why? Okay, how would I do that?
Subtract x from both.
Okay, so like get y all by itself. So if I have x plus 2y equals 3, you want to get y all by itself?
Yeah.
Okay.
Subtract x and divide by 2.
Okay, so I'd have 2y is equal to 3 minus x, and then you said divide by 2.
Get y is equal to 3 over 2 minus 1
Yeah.
half x.
Yeah, minus 1/2 x. Okay, and then you said do the same thing with the other one?
Yeah.
Okay, so if I have the x minus 2y is equal to 4, what would I do, Jaden?
Subtract x and divide by -2.
Okay. So if I divide by -2, what would I have?
Y is equal to -2 minus, or plus 1/2 x.
Yeah, plus 1/2 x. Okay. So now that we have 2 equations that are both set equal to y, Faith, what can I do with those? Jade, help her out. You have an idea? What could I do with it? So if they're both set equal to y, can I just set these two equal to each other? Because if they're both set, like they both equal y, and y is the same thing. So I could set this equation equal to this equation, couldn't I? Do you guys remember this from Algebra 1? Yeah, okay, so if we do that, I'd have -2 plus 1/2 x is equal to 3/2 minus 1/2 x. Okay, so now we need to solve this for x. So Haley Winter, go ahead and help me. What would I do?
Subtract 1/2 x.
Okay. So I'd have
-1x, or -2 equals 3 over 2.
okay. And then what would I do?
Subtract 3 over 2.
Okay. So I'm gonna get. So if we think this is 1/2, right? 3/2 would be 1/2. So if I have -2 minus 1/2, I'd have. So since they're both negative, I'd have.
3.5.
Yeah, -3.5. So I'd have -3.5 is equal to my -x. And what would my last step be?
Divide by -1.
Yeah, if I divide by -1, they're both just gonna become positive. Okay, so I ended up solving and I got my x is equal to 3.5. Is everyone comfortable with that? Yeah, okay, so now we need to go ahead and solve for our y. So because I know that my x is 3.5, how can I now figure out what my y is? Cooper, what do you think?
Just plug it in.
Yeah, just plug it in. Does it matter which equation I put it in? No. So which one do you want to use?
I don't care.
Okay, let's use this one over here. So I'll erase over here. Okay, so if we plug it in to our equation, we can plug it into like an original one, or we can plug it into one that's already solved for y. It doesn't matter, it's all gonna work out the same. So if I plug it in, so I have this y equals 3/2 minus 1/2, and now I can plug in my x of 3.5. Okay, so then now I just need to solve this. So Brayden, go ahead and help me. You can get your graphing calculator if you want to type that in. So if I'm taking negative 1/2 times 3.5,
1 and 1.75. Negative 1.75.
okay. Negative 1.75. Okay, so if I have 3/2 minus 1.75, what am I gonna have now? So this is,
Negative 0.25.
yeah, negative 1/4. Okay? Because yeah, so we know that this was 1.5 minus 1 3/4 would leave me just with negative 1/4. Okay? So then my coordinate, so my x we said was 3.5, and then my y is negative 1/4. So that would be my solution for those two problems, okay? So if I were to graph them, if I were to graph both of these lines and draw them, I know that they would cross, the two lines are gonna cross at 3.5 and then negative 1/4. Is that right? Okay. Is there another way we could have solved this? If you guys think back, Cooper nodded his head. Do you remember how? Plug zeros in. So that would give me my x, like my x-intercept and my y-intercept. So if I needed that, that would be great, but I don't, I just need where they cross. What about, did you guys ever do where you add the two equations, like up and down? Do you guys remember that? Let's do this problem again, but let's do it that way. Because this way is gonna be, it's not always easier, but when we have 3 variables, it's easier to do it this way, okay? So, what I can do is I can just add my two equations together. So if I add them together, what I need is I need some variable to drop out, which in this case, when I add 2y and negative 2y, they're just gonna drop out, aren't they? Like 2y plus negative 2y, they would just disappear. So then I would have x plus x, which is gonna give me 2x. 2y plus negative 2y gives me nothing. And then over here, 3 plus 4 is gonna give me 7. Now if I solve this for x, I can just go ahead and divide by 2. So I'd have my x is equal to 7/2, or we said it was 3.5. Have you guys seen that way before? You haven't? Haley Burry says yes. I actually, I don't care if you haven't, but raise your hand. Have you seen, I don't care if you haven't, because this is just what we're gonna be using. It's gonna be way easier. Have you guys really not seen this in Algebra 1? Jade says maybe. Oh, okay. Okay, so that's interesting. I didn't know you guys didn't know that. Okay, so good to know. Thanks. Okay, so yeah, so you can always just add two equations together. Did that make sense how I did that? Yeah, yep. So the only thing is you always need one variable to drop out. So in later examples, we might have to multiply something by 2 so that I would have, if this was just like this, like x minus y, I would have to multiply this whole line by 2. So then I would have, this would be 8. So then I would have something that would drop out. So you first would have to be able to make something drop out and then solve it from there, okay? So yeah, so then once we have this right here, our x is equal to 3/2, I would just plug it back into one of my equations. So I could put it in the top one, so I'd have 3/2 plus 2y equals 3, subtract my 3.5, so I'd have 2y equals negative 1/2, divide by 2, y equals negative 1/4. So same exact thing that we got before, it's just a different way to do it, okay? But we'll practice it, so since obviously you guys haven't really seen that way, okay? So yeah, so you can always add your equations together. That is super interesting. I did not know Mrs. Porter didn't teach you that, so. Okay, so let's go ahead, let's talk about inequalities before we get into 3 variables, okay? So with inequalities, here's just a word problem to kind of walk us through. So it says, Malcolm's gonna earn $20 per hour mowing lawns and $10 per hour walking his dogs. So his goal is to earn at least $200 each week, but he can only work a maximum of 20 hours each week. And then one stipulation is he has to spend at least 5 hours walking his neighbor's dogs. So at least 5 hours of walking his dogs. Okay, so what we want to do is we want to write ourselves some equations for what's going on, and then we're going to graph them to be able to figure out how many hours Malcolm should work at each job in order to meet all of his goals. Okay, so let's go ahead, let's do our X as the first one. We'll just say that's mowing. So X is equal to our number of hours mowing. And then we'll give Y our number of hours walking the dogs. Okay, because I have two different things, so two different variables to represent them. So doesn't matter which one. I just did X first and Y second. So okay. So now if we're talking about he's trying to earn at least $20 each week. So he earns how much money when he's mowing? 20. So I know if I have 20 times X, so I earn $20 per every hour that I mow. Okay, so 20 times X would be $20 per every hour I mow. Then also, I know if I walk my dogs, walk the dogs, I get $10 per every hour that I walk dogs. So far, so good? Yeah, okay. And I know that I'm shooting, because we're talking about money right here, so $20 per mowing hour, $10 per walking dog hour, and I'm hoping to make at least $200 a week. So I don't want to set it equal to 200, but I want my 200 to be over here. So am I going to want a greater than or a less than or a greater than or equal to or a less than or equal to? What symbol do you think I should put in the middle? Okay.
Greater than or equal to.
Yeah, greater than or equal to. Because all of my efforts over here, my mowing and my walking the dogs, I'm hoping to make more money or at least $200 every single week. You guys okay with how I wrote this? Just talking it through, it makes sense? Okay. Okay, so that's our first inequality. So then the second one we're going to talk about, we talked about the money already. So now we're going to talk about the fact that we can only work $20 or work 20 hours per week. So if I can only work 20 hours per week, how do you think I can write an inequality for that? Does anyone have any ideas? So I'm talking about my hours. So I know I have X is my hours of mowing, Y is my hours of walking my dog. Brayden?
X plus Y is less than or equal to 20.
Yeah, exactly. So X plus Y is less than or equal to 20. So X, the number of hours I'm mowing, plus my Y, which is the number of hours I'm walking my dog, that has to be less than or equal to 20, because I can't work more than 20 hours per week. Okay? And now the third thing, I'm gonna have a third one, because there's one stipulation. So it says Malcolm must spend at least 5 hours per week walking his neighbor's dog. So how could I write an inequality for that sentence right there? So if I have to for sure spend 5 hours walking my dogs. Well, walking my dogs is my Y, right? So I know I'm just gonna care about my Y. I don't care anything about my mowing. So if I have Y, I have a 5 hours. What do you guys think?
Y is greater than or equal to 5.
Yeah, Y is gonna be greater than or equal to 5. Okay, because my number of hours walking my dogs has to be greater than or equal to 5. So far, so good? Yeah, okay. So now to figure out, to answer my question, so now that I have all of these, we're gonna graph each of these inequalities and then it'll answer our question. So we can go ahead and graph these, just like we did in the last section, okay? So, I only need quadrant 1, I don't need 4 quadrants. Okay, so here's my graph. So in order to graph these, just like on your IXL, if it's not set equal to y, what should you do so that we can graph it? Caden? Yeah, get it set equal to y. So this first one up here, I have the 20x plus 10y, and for graphing purposes, we can say that it's equal to 200, and then we're actually gonna end up like shading to figure out the greater than or the less than. But so if I have this one up top, I have 20x plus 10y is equal to 200. How can I solve that for y? Mia, go ahead and help me. How would I get y by itself?
Subtract
Okay. So what would I have?
180.
Okay. Except we're subtracting the 20x.
Oh, 180x.
Does this one have an x on it? So can I combine those?
Oh,
No.
so it would just be x plus 10y.
Yeah, so we'd have like the 10y still, and then we'd have the negative 20x plus the 200. So I can't really combine anything. And then Paige, what would I do from here? Yeah, divide by 10. So what would I be left with?
Just y on one side. 20.
Sorry, I did the other way around in my book.
Oh no.
200, plus.
I think my book is backwards.
That's okay. So if I take my negative 20 divided by 10, what would I have? Yeah, I just have the negative 2x. Yep. And then if I take my 200 divided by 10?
2. 20.
Yeah, 20. Yep, you're good. Yep, so we'd have the y equals negative 2x plus 20. So these are the same exact equation, but this right here looks like something I can graph because I have a y-intercept and a slope. Versus this up here, I wouldn't know how to graph that. Okay, then let's go ahead, let's get our other one ready to graph as well. So if I have x plus y is equal to 20, Haley Burry, what would I do with this one?
Minus x.
Okay, so what would I have?
Y equals 20 minus x.
Yeah, the negative x plus 20. Okay, all right, so let's go ahead, let's graph these. I'm gonna count by 5s going up, so 5, 10, 15, 20. Okay, so 5, 10, 15, 20, 25. Okay, so we're graphing these 3 lines now. So this one right here, if I have y equals 5, how do I graph that? Faith, what do you think? Yeah, for the y equals 5. Okay. That's just gonna be a horizontal line at 5. So it's gonna be something just like this. Okay, so here's my first one. We got that one all graphed. I'm also gonna count by 5s on the bottom, guys. So 5, 10, 15, 20. Okay, so then the next one, we can graph the negative 2x plus 20. Mackenzie, where would that y-intercept be? Yeah, up at 20. And then what's my slope? Yeah, down 2 over 1. So basically, since I counted by 5s, so if I were to go down 2 over 1, if I go down 2 chunks and over 1 chunk, I'm going to be at the right spot because I counted by 5s. So I would have a point right here at 510 because I went down 2 chunks over 1 chunk. Then if I go down 2 more chunks over 1 chunk, I know that I would have this point at 10. So here would be my second line, okay? So I have that point at 10, 0, that's my x-intercept. Okay, so here's my second line, this negative 2x plus 20. And then the last one, so we need to now graph negative x plus 20. Cooper, how would I graph that one?
Go to 20.
Okay. And then my slope would be,
Is it negative x or negative 2x, whichever?
we're doing this bottom one now.
So just negative 1.
Yeah, negative 1. So if I go over 1, down 1, so I can go over 5, down 5, over 5, down 5, since I counted by 5s. Over 5, down 5, and then I cross out here at 20. Okay, so I start up here, and I'd have this line right here. So same y-intercept, but this one has half as steep of a slope, so it's gonna look just like that. Okay? So we have all the lines graphed. Now the only tricky thing is now we need to think about the inequality piece. So if it says my y is greater than or equal to 5, well here's my line of 5. The stuff greater than that, is that gonna be above or below the line? Caden says above. Yeah, it's gonna be the stuff above, so I'm gonna go above. Now this one over here, this first one, this was this equation right here. So this line, the first line that we graphed, it's gonna be greater than or equal to 200. So this line right here, if it's greater, so think about your x's and stuff, are the x's greater on this side or on this side? On the left or the right? Which side has bigger numbers? Yeah, they're right. So it's gonna be this line, I know I'm gonna shade on this side right here. Okay, because it was this equation, and then the equation is greater than or equal to, and the numbers greater are the ones on the right side. Okay, and then the last equation, so this line right here, when it's less than or equal to, if it's less than, is it gonna be the numbers on the left or on the right? On the left. So all of my arrows point to just this piece right here. So this, all of this right here would be the answer to my question. Okay, so when it says, for how many hours should Malcolm work at each job in order to meet his goals? Well, as long as I pick any set of numbers in here, like if I pick 10, 10, well that's in here. Or if I were to pick 7, 12, well that's in here. So if I pick any set of numbers that's in this area, that's gonna fulfill all of my goals. I'm for sure gonna walk my dog for 5 hours. I'm gonna make at least $200 and I'm gonna work under 20 hours. Okay, so that would give me everything that I'm looking for. Okay, so then here's a picture of kind of just what's going on. So we just drew that exactly on the board. But yeah, so here's the same graph we just drew. But like I said, for our solution, we could mow the lawn for 12 hours and walk the dog for 7, because here I am at 12, 7, well that's gonna be inside of our triangle. Or I could mow the lawn for 5 hours and walk the dog for 12. So if I mow for 5 and walk the dog for 12, I'm still gonna earn $200, work less than 20 hours, and walk my dog for 5 hours, okay? Does that example make sense? Do you guys feel like you could figure something like that out on your own? Yeah, okay. So then the last thing for today is just solving equations, just like we did on the first slide, but this time we're gonna do it with 3 variables. And here I just kind of made up some steps that is exactly how you're gonna do it. It's just the easiest way to remember exactly what to do. But so you're gonna have 3 equations. Of those 3 equations, you're gonna pair them up into 2 sets. So you're gonna put 2 of them together and then put 2 of them together. It doesn't matter which 2 you put together. So usually I just do the first and the middle one and then the middle and the last. Okay, so you're pairing them up. So we start with 3 equations and then we have, from the 3 we put 2 together and then we put 2 together. So then it says we're gonna work with each set individually to eliminate the same variable from both sets. So this is important. So we're gonna be doing that adding, up and down method. So we're gonna work with them, and from both sets, we have to get rid of the same exact variable. Okay, so it can be X, it can be Y, it can be Z, whatever you want, but you have to get rid of the same one from both. So then after you eliminate that, now you have two equations that just have the same, like say you eliminate z from both of them, now you're left with two equations that both just have like x and y in them. Okay, so then those two new equations, we can take those and we can solve them for just one variable. Okay, because you just have your x and y and x and y. If we add those together, we can get rid of x or get rid of y, and now all of a sudden we've solved for one of our variables. Okay, so then once you've solved for the one variable, you can take that number and plug it back into one of the equations that you solved, one of the ones that just has the two variables to solve for the second variable, and then take both of those answers and plug it back into an original equation to figure out what your third number is. Okay, so it's just a little bit longer than what we did before because we have three variables, but it's the same exact idea. Okay.
Are we done or are we just sitting here?
No, we're just waiting. People are writing.
Oh.
We're just hanging for. Some people are writing things.
Okay, so let's go ahead, let's do this one. All right, so I have three equations. So x plus y plus z equals 3, x minus y plus z equals 1, and then x plus y minus z equals 2. Okay, so from those three equations, the first thing I want to pair them together. So I'm going to put my top two together. So I'd have x plus y plus z equals 3. And then my next one, I have x minus y plus z equals 1. And then also, now I can put the second and the third one together. So I'd have x minus y plus z equals 1. And x plus y minus z equals 2. Okay? So now what I want to do is I want to add these together. I'm going to do the same thing over here, so I'll add my lines together. Looking at this, if I just add these together, is one of my variables going to drop out right away for us? Kaden, which one is it going to be? Yeah, my y is going to drop out because the y plus a negative y is going to disappear. Okay, so all we're going to do, so x plus x would give me what? 2x, okay? And then we just said the y plus the negative y is going to disappear. Z plus z, what does that give me? 2z. And then 3 plus 1 would give me 4. Okay, so now I have this equation. So now we need to do the same thing over here. So over here, I need to make sure the same variable is going to disappear. When I add my y's together, are those going to disappear? Yeah, so we can go ahead and add. So x plus x is going to give me 2x. The negative y and the y gives me nothing. The z and the negative z would give me nothing. And the 1 and the 2 would give me 3. So for us, this is easy now because I actually had two variables drop out. So I can go ahead and just solve this one for x. So to get x by itself, what would I need to do? Braden? So I'd have
3, x equals 3 over 2.
Yeah, x is going to equal 3 over 2. Okay? So if you ever have two of them drop out right away and you're left with just one, go ahead and solve it because we already have one answer then. So now because I have an x, can I go ahead and plug that x in over here and solve for my z? Yeah, so let's go ahead and do that. So then I'd have 2 times 3 halves plus 2z equals 4. Mackenzie, go ahead and help me with this one. Okay, what would that give me? So if I think about my fractions, so this is 2 over 1, so 2 times 3 would be
6.
over 2.
Which would simplify to
Yeah, exactly, yep, so I just have 3. And then plus my 2z equals 4 still. And then what would I do, Mackenzie?
3. And we would minus 3 on both sides.
Okay.
Which would give you 2z equals 1, and then we would divide by 2 each side and have z equal 1/2.
Yeah, exactly, yep. So we have our x and our z now. So now I just need to figure out y. So I can go ahead and take those two and plug them into any of my equations. It doesn't matter which one, but just plug them into one of your original equations. So let's go ahead, let's just use the top one. So I'm gonna use x plus y plus z equals 3. And then my x we said was 3/2. We don't know my y yet, but my z is 1/2 is equal to 3. Then Haley Winter, go ahead and help me solve this one.
It'd be 2 plus y plus 3.
Okay.
And then you have to subtract 2. And y equals 1.
Yeah, so y equals 1. Okay, so then your solution, just like how we write coordinates like x, y, well the z is just the last one, so if we write our solution out, my x is 3/2, my y is 1, and then my z was 1/2. And you gotta make sure they go in the right order, so x, then y, then z, okay? So if I were to graph, so the z is actually in like 3D, but we won't do anything with that besides solving. We're not gonna like graph in 3D or anything this year. So basically if you were in 3D, the point where all 3 of those lines would cross would be at 3/2, 1, and then 1/2. Okay, do you guys feel okay with that? Okay, so the very last example, this one's just a little bit trickier because the numbers aren't as nice for us, but this is our last one. Okay, so I want to start, I just pair up my first 2 equations and then pair up my second 2 equations. So this time I would have 2x plus y minus z is equal to -10. And then I have negative x plus 2y plus z equals 3. And then over here, I can do the negative x plus 2y plus z equals 3. And then x plus 2y plus 3z equals 13. Okay, so looking at this, does any variable drop out nicely for us? Z, yeah, the negative z and the positive z, those are gonna drop out. Okay, so then if I have 2x plus negative x, what would I have? X. And then if I have y plus 2y, what would I have? 3y. And the z and the negative z gives me nothing. And then the negative 10 and the 13 would give me, yeah, -7. So once I add my 2 lines, I end up with x plus 3y equals -7. Is everyone okay so far? Yeah, okay. So now over here, if I add these 2 lines together, does anything drop out nicely over here? X, but can I drop out my x if I have x left over here? No, so I need to get rid of my z over there, that's the thing. So because I got rid of z over here, I have to get rid of z over here. Okay, so, sorry my 2's and z's look so much alike. This is a z. Okay, so if I have z and 3z, what do you think I can do to get those to drop out? Kaden?
Multiply the top one by -3.
Yeah, if I multiply my top one by -3. So when I do that, I multiply everything in the whole row. So both sides have to get multiplied by that number. So if I take -x times -3, what would I have?
3x.
Positive 3x, yep. And so I'm not actually adding these, I'm just rewriting my top line, okay? So my top line is gonna be this now, once I multiply by -3. Okay, so then my 2y times -3 would give me -6y. And then my z times -3 would give me, what did we say on that one? -3z. And then 3 times -3 would give me, yeah, -9. Thanks, Brayden. Okay, so I have to multiply everything by whatever number I need to get everything to drop out. So both sides. So don't forget, a lot of times people forget to do the constant on this side. Okay, so you have to do the whole thing. Okay, now I can just copy down this other line because now we should be able to get some stuff to drop out. So now that I have those set up, I can go ahead and just add the lines together. So 3x plus x, Jade, what's that gonna give me? 4x. And then Jade, -6y plus 2y would give me?
4y.
Okay. My -3z and my +3z.
Nothing.
And then my -9 plus 13?
4.
Yeah, 4. Okay. So now I have two equations that only have x and y left in them. Okay, so now I can go ahead and put those together. Okay, so from here, I'm just going to bring that over here. So I have this equation right here, and I have the 4x minus 4y is equal to 4. When I add these two together, is one variable going to drop out? No. So, Haley Winter, what do you think I should do?
Multiply the top equation by -4.
Yeah, if I multiply my top one by -4, then that'll give me -4x, which then will cancel with my x. Okay, so now when I multiply it by -4, if I bring that down here, so -4 times x, I just said it was -4x. 3 times -4 would give me, Cooper, what do you think? Okay, so I have -12y. And then -7 times -4, Cooper, would be? If I have two negatives? Yeah, +28. Okay. So this new line, so when I multiplied it by -4, it became this line down here. Okay. So now I can add these together. Okay. So we'll add them together super fast. So the 4x and the -4x gives me nothing. The -4y and the -12y would give me -16y. And then the 4 and the 28 gives me,
32.
okay, if I divide by -16, I have, yeah, my y is going to equal -2. Okay, so then tomorrow we'll finish this. We would just end up plugging our -2 back in to a different equation, solve for x, plug them both in for z. Okay, but that was everything. So if you want to start any of the homework, you can get started on that because you guys should feel comfortable doing everything. Okay, all right. Any questions, you guys? How did everything go today?